Hi guys, Brendan from Steve Sorensen Mechanical here. Today we've got a 2010 K13 Nissan Micra with an intermittent, very intermittent, cutting out problem. So let's take a look and see if we can diagnose it. Okay, so our Micra here, the customer has complained that in the last couple of weeks it's cut out twice on them. Most of the time when they go to crank it to start it, it'll take a little bit of time to get going, so it's not just a die and restart, it's die and then it takes a while to get going. Not too many other details aside from that, and I've been for a bit of a drive, very intermittent. Taken a look on the scanner, no fault codes, so nothing to give us direction like that. So basically from here we need to experience the problem. So this is our vehicle here, the Micra. I've been for a 10-minute drive while monitoring some key parameters on the scan tool. So I just drove around while monitoring the data that it gave us. Most importantly, RPM, since Nissans are pretty bad for crank angle sensors, mass airflow, battery voltage, all those kinds of things. Drove absolutely fine, so I had no problems. So I wasn't actually able to experience the fault, so start with the basics. I've tested the battery, so just capacitance testing the battery, it's absolutely fine. I believe we changed it about a year ago. Tested the alternator charge rate and it's perfect at around 14.1 volts. I've then done a voltage drop test from the positive terminal of the battery down to the alternator positive terminal, and there's no voltage drop there. Also voltage drop test from the negative terminal of the battery down to the chassis and also to the engine block, and we have basically no voltage drop there. So a couple of basic tests. It did eventually start to play up on me, so I left it idling for about half an hour, and I came over while I was still recording on the scan tool, came over, the car had stopped, so I quickly jumped in here, and on the snap-on it was recording, so I quickly pressed the save button up here. We can do it again now, and so that saves the recording that was there. Luckily, there's a bit of a buffer there of say 5 minutes. Luckily I was able to catch it. Okay, so I then took my scan tool and I've hooked it up to my laptop here that's running the Snap-on ShopStream software. So I can go in there, select my movie that we've just recorded during the event. Straight away, pretty clear, we can see that it was idling nicely, and then it started to, looks like it probably spluttered to a death rather than just a straight cutout. I can see air fuel alpha, which on these is their fuel trims, it really started to ramp up, so it was running lean, and it tried to increase the fueling. Probably gives me my injector pulse width here somewhere. There's my injector pulse width. If I move that up here so it's viewable, yep, so it really started to open those injectors up in an effort to try and keep it running, but it couldn't, and eventually it died. So that's really good direction. From that, I think that we should start chasing the fuel system, really, because it seems that way. When I tried to start it, it definitely felt like it was starving for fuel. I could see the tacho moving, so I don't think it's a crank angle sensor problem. I could see RPM on the scan tool as well, and it felt like it was trying to start, but any throttle and it would just die and it spluttered. So I think we do have an intermittent lack of fuel problem. Okay, so I've spoken to the customer, and at this point they're happy to go ahead with some further testing. So we're going to look into this fuel system and hopefully catch it out. So I got a wiring diagram, and our fuel pump is fed by what you would traditionally call a fuse relay box, but these, I think they call them an intelligent power distribution module. So it's one of the sort of computerized relay boxes here. I found the output for the fuel pump, so this brown wire here. I'm monitoring the voltage coming out of it, the amperage on that circuit, and then if we go down into the car, I've got a fuel pressure gauge hooked up so I can see the actual fuel pressure, and I'm monitoring the power at the fuel pump, so it's the same as that brown wire back at the module. It goes through a connector, turns into a green wire and feeds into the pump, so I want to make sure that I'm getting the same voltage reading down here and we don't have a drop along the line. Easier to pierce this wire. If I was to back probe in there's a good chance I'll short it out on this chassis here and we'll have a problem on our hands, so sometimes you just have to pierce the wire. Got all of that hooked up to my scope up here. Sorry, the other thing that I'm monitoring is a camshaft position sensor. So down here, tucked away under there, I'll try and get you under. Oh, no, a bit too difficult, but camshaft position sensor, because basically if I see this fuel pump drop off, I want some indication that the engine's still running, or else I'll come back over, find the car dead, and say, okay, the fuel pump shut off, but what actually happened at that point? So if I start the car up now, and I'll take you back to the picoscope. And so we can see our blue trace channel 1 is the amperage of the fuel pump. Channel 2 red is the voltage at that fuse box. Channel 3 green is the voltage at the fuel pump, and channel 4 yellow is my camshaft position sensor. Now I've got this on a very long time base, and I've changed my amount of samples, not samples, but sort of waveform buffer, so I can capture a lot of them, because I want to leave this thing sitting here for, you know, an hour or however long it takes until it actually cuts out, and I want to make sure that this doesn't stop recording. So that's just, I've set that to 10,000. It's just going to keep going. I'm on a very low sample rate because I don't want this massive buffer happening over here and I could miss the event. And I've got a 1 second per division, so each one of these divisions is 1 second, because I want to capture quite a lot on this screen. And as you'll see, if I was to pause this, the beauty of the picoscope is I can still zoom in and get quite good detail. So there's our fuel pump, and it's got quite good detail. I could go in and see the cam sensor, still great. So get great detail even though we're on quite a long time base. So basically I'll let that go, and hopefully this car will cut out. Okay, great news. So I believe we've caught the event when it has cut out. So it was running for about 45 minutes, an hour in the corner of the workshop, trying to recreate the conditions. So I had the bonnet down to build heat in the bay, had a lot of loads turn on since we're thinking it's an electrical problem, so I wanted to stress all the systems out. And I came over and it had eventually stopped, and I believe I can see what the problem is. So we can see with the red and green traces we are getting power to the fuel pump. We can also see that the camshaft signals are still going. The very low voltage that we see at the start of this is likely because it would have been bucking and kicking and the alternator was struggling to keep the charge up. But we can see that our fuel pump is doing absolutely nothing. So we were running quite a bit of amperage before, absolutely nothing now, even though it's getting power. Come across, and this was me when I just caught it. Then I've come across and I've tried to crank the car, so I could see on the fuel pressure gauge there was no fuel pressure. I've cranked the car, I can see that it's getting power, I can see nothing's happening amperage wise at the fuel pump, and then quickly I jumped out and tested the earth of the fuel pump just to ensure that we had a good earth there, which we did. So there's no reason that this fuel pump should not be pumping. We had no fuel pressure, the pump's got good power and earth. This thing needs a fuel pump. Intermittently stopping the fuel pump when it gets hot, warm, whatever the case may be. But yeah, I think we've nailed this one. Got our old and new assembly here, so had a look, and there's no reason that I can see that wiring wise this would be failing. So resistance tested through these wires, no burnt terminals in there. Importantly, no burnt terminals on there or the old plug, so I don't think we've got anything going on there. I think we've just got a fuel pump that is failing. So we're going to get this new unit in, and I'll let it idle and redo a bit of testing to make sure we don't have a recurring problem, and should be on its way. We've got our new fuel pump in there, so all fixed. So I'm just going through, taking a look at the known good. Before I send this out, I want to have a better look at that fuel pump. So our blue trace, we're still watching the amperage of the fuel pump. Now instead of being at 1 second per division, I want to get right in on that. So I'm going to go 10 seconds per division, and we can see this beautiful picture perfect waveform of a fuel pump, and I can measure the rotation of that. So if I get some cursors, we'll pause it first. So pause, get some cursors. Now there's 8 segments to this fuel pump. Not going to get too picky, but if we go there, we count out 1, 2, 3, 4, 5, 6, 7, 8. Or using a laptop, so it's not the easiest. Okay, there. And so this tells me that I'm doing 5,700 RPM, which is pretty great for a fuel pump. I usually like to see them around that 6,000 RPM section. So we've got nice even segments, and we're doing about 6,000 RPM, not pulling too much amperage. Usually I'll see them a little bit higher than this, around sort of the 5 amps or so. but this is a good fuel pump. I'm going to leave it run for half an hour to see if we have any further problems with it, but quite confident we've fixed this one.